Molecular orbital diagram of benzene. So before talking about molecular orbital diagram, we need to know the molecular orbital theory for cyclic compounds. So energy of molecular orbital for cyclic compound is given by Huckel approximation. So what does this Huckel approximation says? It says that EJ is equal to alpha plus 2 beta cos 2 j pi upon n. And here alpha denotes to the energy of a single electron, beta denotes to overlap energy, or you can say energy gained by electrons due to overlap, and here is number of p orbitals participating, and I the value of, if n is equal to 3, so then the values of I will be 0, plus 1, minus 1. Okay, and if n is equal to 6, the value of I will be 0, plus minus 1, plus minus 2, 2 2 4 5, plus 3. So here in this way we'll get the value of I with respect to n. So now talking about benzene here. So for diagram of benzene, molecular orbital diagram of benzene, we need to find energies for n is equal to 6. So how we'll find it? Let me erase this term. Okay, now for benzene, n is equal to 6. N is equal to 6. So the values of J will be 0, plus minus 1, plus minus 2, and plus 3. So these will be the values of J. Now, according to Huckel approximation, we have EJ is equal to alpha plus 2 beta cos 2j pi upon n. So putting these values of J in this equation, for J is equal to 0, or E0 is equal to alpha plus 2 beta cos 2 into 0 into pi upon n. N here is 6. So it will come, cos 0 is equal to 1. So we'll get the result alpha plus 2 beta. Now E plus minus 1, E plus minus 1, what? Substituting the value for J here, alpha plus 2 beta cos 2 into plus minus 1 into pi upon 6. So solving this particular, so in E0 here, this is xi1, wave function xi1. Now here we will get two values, of course, xi2 and xi3. So if you solve this particular equation, you will get alpha plus beta. You can take time to solve it. And now E plus minus 2 is equal to alpha plus 2 beta cos 2 into plus minus 2 into pi upon 6. So solving this, we will get 1 alpha minus beta. Why? Because 2 into 2, 4, 4 upon 6 pi, here 4 upon 6 pi, and the result will be minus 1 by 2, and 2, this 2 and this 2 will be cancelled out, so result will be alpha minus beta. So in second equation we will get xi2 and xi3, these are wave functions, and here xi4 and xi5, these are wave functions. So talking about E3, E positive 3, we will get alpha plus 2 beta cos 2 into 3 into pi upon 6. So this will come to alpha minus 2 beta. So this will be our xi6. So we get all the wave functions related to this particular energy for benzene. So now talking about diagram. Remember these values. In the next page, I will use these values for drawing the molecular orbital diagram for benzene. Now this is our energy representation, and this will be our non-bonding, and these are orbitals. Okay, so first one was xi1 was, this is xi1, this is xi2, this is xi3, this will be xi4, this will be xi5, and this will be xi6. So these are bonding, these are anti-bonding orbitals, and in center we are getting non-bonding. So filling up the electrons, 1 2 3 4 5 6. We know that benzene has 6 pi electrons, so we filled up all the electrons and we are getting nothing in anti-bonding. So xi1, talking about xi1 is strongly bonding. What type of orbital this is? This is strongly bonding. And xi2 and xi3 are weakly bonding. And talking about xi4 and xi5, so this is This is also weakly anti-bonding, and this xi6 is strongly anti-bonding. Now writing their names also. This was our alpha plus 2 beta. This was our alpha plus beta. This was our alpha plus beta. This one was alpha minus beta. This one was alpha minus beta, and this one was alpha minus 2 beta. So this is molecular orbital diagram for benzene. Oh, so this particular question is solved here, but we need to, if we further need to draw some conclusions that why benzene is so stable, why it is chemically, why it is thermodynamically and kinetically stable, we need to do little bit of more calculations. So what are they exactly? What we need to find for proving its stability? We need to find the energy of conjugation and energy of hypothetical situation of unconjugated system for C6. So then we will get the resonance stabilization energy, and for that particular energy, we will be able to draw a conclusion that why benzene is so stable when we compared to some other compounds having 6 atoms of carbon. So okay, let's quickly do those calculations. Now, according to Huckel theory, the energy of conjugation is given by J is equal to 1 Ni Ei. So solving for energy of conjugation for benzene, so we know that for N we will be having the value of 2 into alpha plus 2 beta, because in N1 we had 2 electrons in particular orbital. That's why I'm writing the value of Ni here, 2 plus 2 alpha plus beta. So these are orbitals that we drawn earlier in the diagram. Okay, so 2 into x plus beta plus 0 into x minus beta. So we know that there were no electron in antibonding. So in xi 4, actually the electrons were 0. That is why we are writing here 0 into xi minus b alpha minus beta xi alpha minus 2 beta. So actually from where I'm getting these values, because I know that energy of Ei for j is equal to 1 was alpha plus 2 beta. So this was the value of xi1. This was the value of energy for xi2 and xi3, xi4, xi5, xi6 respectively. And why I wrote 2 in place of n, because there were 2 electrons in each orbital of bonding, and there were 0 electrons in each antibonding orbital. So calculating these, we get that 6 alpha plus 8 beta. So what is this? This is energy of conjugation for benzene. Now remember this particular value. I'm erasing it. Now we will solve for, we will consider a hypothetical case in which there we will calculate the similar system in which we will calculate the energy of unconjugated system. So energy for unconjugated system is given by nj alpha plus beta. So this is formula for it. Now we know that what n representing here is, n is representing number of electrons, 5 electrons actually, n alpha plus beta. So this will come out to this. And now what is resonance stabilization energy? Resonance stabilization energy is energy of conjugation minus energy of unconjugated system. So this will, in earlier equation we got that energy of conjugated system for benzene is 6 alpha plus 8 beta, and for hypothetical situation for similar system we have 6 alpha minus plus 6 beta. So solving this, we get resonance stabilization energy is equal to 2 beta. Okay, so I told you earlier that what is beta here? Beta is overlap energy. So whenever resonance stabilization energy becomes twice the overlap energy, then the compound become aromatic. This you have to remember. Okay, so all aromatic compounds having completely filled bonding orbitals, while the number of electrons in anti-bonding are 0, are kinetically inert and thermodynamically stabilized. Okay, and also you need to remember that higher the resonance stabilization energy, higher will be aromaticity. Okay, so this is done and dust here. Thank you for